Alright everybody, we're going to do a video lesson here on 1.5 angle relationships. This is our last lesson in chapter 1, and it's going to really build off of what we did last class when it came to naming and classifying angles by points that lie on those angles or by the vertex of an angle. So the first relationship that we're going to look at is called vertical angles, and vertical angles are specifically two angles whose sides, and remember, sides of an angle are always made up of the rays that intersect at the same vertex, whose sides form two pairs of opposite rays. And we're tying in here some older vocabulary from chapter 1 with our new angle relationship of vertical angles. And I'm going to use my highlighter tool here just to help you visualize what are vertical angles. So vertical angles would be angles that share a common vertex and their sides form two opposite rays. So right here between angle 1 and angle 3 I have one ray going this direction, and its opposite ray in orange here would be going off in the same vertex but in opposite directions. So there is one ray, there's a pair of opposite rays, and if I use my blue and red here, I have another set of opposite rays going in this direction, and in red here I have a ray in the opposite direction. So the angles whose sides form two pairs of opposite rays, those angles that are opposite of each other, opposite, vertical, right? Those angles are going to form vertical angles. So real quickly here, if I wanted to name an example of opposite vertical angles, I would say angle 1 is a vertical angle with angle 4, right? Another possible combination we could look at is angle 3 would go with angle 2. Okay? So those are examples of vertical angles. Linear pairs, and let me just erase here real quick so we can re-highlight our picture if we need to. Okay? Linear pair angles are two angles that have to be adjacent, so two adjacent angles whose non-common sides, non-common means they don't have them in common, non-common sides are opposite rays. That's why it was very important back at the beginning of chapter 1 that we can identify where opposite rays were located. So angles, also it's helpful to understand linear pairs are examples of angles that are supplementary. Angles are supplementary. So let's go ahead and quickly identify opposite rays here. Let's say that here's my vertex, and let's say I go off in one direction this way. This ray is going to be an opposite ray with this ray, right? And since they're opposite rays, the two angles that are adjacent to each other, in this case angle 1 would be adjacent with angle 3, and therefore angle 1 and angle 3 would be a linear pair, angle 1 and angle 3. Now on the other side of those two opposite rays you also have 4 and 2. So that would make angle 2 and angle 4 opposite rays. Now Mr. Ausel, since these angles are vertical, wouldn't also, if this is a ray going right here, and that ray is opposite of this ray in this direction, couldn't we also say that 3 and 4 and 1 and 2 are also linear pairs? Yes, that's true. So as long as we have a pair of opposite rays, the two angles that are next to each other by their non-common side, right, form the opposite rays, those two angles have to be a linear pair. Now adjacent angles is even more vague when it comes to describing that. Adjacent angles just have to be two angles that share a common vertex a common side, and have no common interior points. No common interior points. Now we talked about this last class in terms of what makes two angles adjacent, and we just want to make sure we review what that looks like. So there's three criteria. Is there a vertex in common? Do they have a side in common? And do they have no interior points, meaning one angle is not inside the other? So we're going to go ahead and take some time here and try some examples of vertical and linear pairs. So real quickly here, we're going to look at our diagram, and we're going to name angles, or determine if the two angles named are vertical or linear. We're classifying them, or we're kind of understanding their relationship. So let's zoom in here a little bit so we can see this a little better. So in letter A of example number 1, they wanted to know if angle 1 and angle 3, if their relationship with each other is either vertical, a linear pair, or neither. So the first thing I might want to do is identify on my picture what's the relationship that angle 1 has with angle 3. So the first thing I want to look at is if they're going to be vertical angles, they have to be made up of two pairs of opposite rays. So first of all, I notice that this ray right here is opposite of this ray, so that's a good sign. But I have a little bit of a problem here when I look at my other two sides of my angle. This side and this side do not form opposite rays because they don't form a line, right? They don't go in exact opposite directions. They kind of go off at an angle. So the first thing is vertical angles are out for this example. Now to see if they form a linear pair, I need to have two adjacent angles whose non-common side form opposite rays, and they have to be adjacent, meaning they have to share that common side. So when I look at this, they do have a pair of non-common sides that are opposite rays, right here in orange. However, when I look at my green rays, they don't share that ray. They have angle 2 in between them. So this is an example where they are not linear pair, they're not vertical angles, so therefore angle 1 and angle 3 would be neither. Neither. Now let's look at 2 and 3. 2 and 3, I'm just going to erase my scratch work here just so I can get a better picture here. So let's go ahead now and look at 2 and 3. 2 is located right here in red. 3 is right here. And the first thing I recognize is that they do share a common vertex. They also have a common ray in between. And they don't overlap at all. So the first thing that pops on my head is they're adjacent, right? They're adjacent. But that wasn't what I was asked to find. I was asked to determine if they were a linear pair or vertical. Vertical are not adjacent. So again, vertical angles are not adjacent. So that kind of takes that guy out of the running. However, linear pairs are adjacent. So I need to make sure that they don't fit my definition. So when I look up above here at my definition for linear pair, there are two adjacent angles who share a common side to make opposite rays. Do any of these rays, there's one shared common, by non-common, do they form opposite rays? No, they don't. So since those two rays, those two sides are not opposite rays, this would be another example of neither. Of neither. Alright, scrolling down here, let's look at our next example, 4 and 5. We'll look at angle 4 and angle 5. So it looks like they have one pair of sides that form opposite rays, and they have a common side as well. And since they form one pair of opposite rays and these are supplementary angles, we can say angle 4 and angle 5 form a linear pair. Five and 8. And remember, anytime throughout a video, if you feel like you're getting the hang of it, you can always pause the video, try a couple problems on your own, and then go back and watch the video to see how you did. So we're going to look at 5 and 8 here. I might need to erase my color work here just so I can see a little bit better. So let's look at angles 5 and angle 8. It looks like they're across from each other, but let's just make sure I'm forming opposite rays here. This is a ray going off in one direction. Here's its opposite ray going in the other direction. And in purple here, I have the other side. That ray matches the opposite side of this angle. So because they're formed by two pairs of opposite rays and they're opposite of each other, these would be vertical angles. Scrolling down here, let's look at 4 and 9. 4 is right here, 9 is right here. And it looks like I'm going to be in that same situation I was in with 8 and 5. Here's a pair of opposite rays. Here's another pair of opposite rays. So therefore 4 and 9, since they're opposite, they are going to be vertical angles as well. 5 and 6. Go 5, and here we go 6. Now what makes 5 and 6 different is, in all these cases we've talked about, we've always had adjacent angles, or we've always had a common opposite rays. But here I have an issue because 5 has a vertex over here, and 6 has a vertex over here. All of our examples of vertical and linear pairs were angle relationships where they had a common vertex. So this is a clear indicator that this is going to be neither of those two relationships. Neither opposite rays, vertical angles, or linear pair. Now let's look at 1 and 4 last but not least. 1 and 4. 1 and 4, kind of that same situation, right? Here's one vertex for angle 1, here's a vertex for angle 4. Since they don't have a common vertex, this would be an example of neither of these two relationships. Alright? So now that we've gone through a couple examples and we've labeled our picture and used the definitions of linear pair and vertical angles to determine if angles were one of those relationships, why don't you go ahead and try these 4 on your own and see if you can classify them as linear pair or vertical angles. What I'm going to do at this point is give you a chance to pause the video, and then I'm going to throw up my answers and you can see how you did. Okay? So looking at letter A, you should have got 2 and 5 were formed a linear pair. 4 and 7 were neither. 8 and 10 were vertical angles. And 3 and 10, since they don't have a common vertex, these would be neither as well. Okay, remember when you're classifying here, use your image to your advantage and try to highlight and color and look at the definition and see which characteristics it has or does not have. Okay? So now we're going to go ahead and, of course, add some algebra into this so we make sure we are keeping up with those skills and using them. So the first thing it's good to recognize is that vertical angles, in terms of how they're formed, also give me that they have to be congruent to each other. So vertical angles, it's good to write down here, vertical angles are congruent. So if vertical angles are congruent, that means that their measures have to be equal to each other. So vertical angles are congruent. That's an important thing to add down to your notes. Because they're congruent, I can go ahead and take the angles that they give me, this angle and this angle, since they're vertical, and we can set those two expressions, 7x plus 30, equal to 11x minus 24. Because vertical angles are congruent, we can set their measures equal to each other. So when I simplify this, I'll probably subtract 7x from both sides and add 24. What that ends up giving me is 54 is equal to 4x. And then what I'm going to do is I'm going to go ahead and simplify that by going ahead and dividing both sides by 4, and x equals a decimal of 13.5. Now let's go ahead and use 13.5 to answer the question that they originally asked us. They said make sure you find the value of each variable to the nearest tenth, and be sure to write the equation and circle your answer. So they want me to find the variable to the nearest tenth, and they don't say anything about finding the angle measure, so I'm going to go ahead and stop at that point and just circle or box my final answer. Okay? Same thing's going to be true here looking at number 2. Now number 2 is a little different because now we're talking about the relationship of a linear pair. Since they're adjacent and they form one pair of opposite rays, we can say that linear pairs sorry, handwriting's really bad there. Linear pairs are supplementary. Now, supplementary is a word we learned back at the beginning of Chapter 1 and also in Chapter 2. Was supplementary meant that their angles have to add up to 180 degrees. So here we know that this angle right here, 25x plus 8, plus my second angle, 9x plus 2, their sum has to be equal to, their supplementary has to be equal to 180 degrees. Now you might be asking, how do I remember supplementary and 180 degrees? I'm not usually really good at definitions. Well, think about the word supplementary. There's two p's in supplementary, and p's kind of sometimes get flipped around and look like 9s. And if I had 90 plus 90, right, that would add up to 180. Also, I've seen some people look at the s, and they've kind of added a 1 and turned that s into an 8, right, and they think 180. So whatever helps you in terms of remembering that, you want to make sure you follow some type of pattern to help you remember. So now let's go ahead and solve this equation. I'm going to add my like terms, so 25x plus 9x is going to give me 34x. 8 plus 2 is going to give me 10. And then I'm going to go ahead and subtract 10 and divide by 34, so I'm going to get 170 divided by 34 is what x equals. And it comes out to a nice number when I put that in my calculator, and x equals 5, making sure that I box my final answer here. Okay, there we go. So we've gone over some example problems here for my notes in 1.5, and now we're just going to do some more practice just to make sure we're understanding the relationship, setting up the right equation, and then solving for what they're asking me to find. So let's jump down to the next page here. And let's go ahead and try to solve for my variables here for 3 and 4. Now this is a little tricky because we've added a new variable into our problem, and let's zoom in here so we can see this a little bit better. In number 3, we have two different types of variables. We have an x in this equation and this equation, and we also have a y in this equation. So it's always helpful to remember when you're trying to solve for variables, you always want to solve for one equation at a time. And whatever variable you have more of, you want to set up that relationship, solve for x, and then use that angle relationship to find the other missing variable. So since I have two x's, let's go ahead and set up that relationship first. So because these angles form a linear pair, what I'm going to do is I'm going to set 8x minus 5 plus 10x plus 14 equal to 180 degrees, since linear pairs are supplementary. Then I'm going to go ahead and add my like terms. I'm going to go ahead and undo addition, subtraction, and multiplication, division. And when I do that, I end up with 171 divided by 18, which x ends up equaling about 9.5 using my calculator, 9.5. So 9.5 is the value of x, but to help me figure out its relationship with y, I need to understand what's the relationship that this angle has with this angle right here. Since they're opposite each other and formed by two pairs of opposite rays, I know that they're vertical, and if they're vertical, that means they have to be congruent. So 8 times the value of x minus 5 is going to be equal to 20 y plus 1. Now I'm going to go ahead now and plug in my value of x into my x equation. Now I have one equation with one variable, and it's pretty easy to solve that. So 8 times 9.5 is going to give me, I'm sorry, I'm going to have to do a little mental math here. 8 times 9 is 72. Hold on, let's think about this. 8 times 9, yeah, that's 72. And then what I'm also going to do is I'm going to multiply the 8 times 0.5, 1/2, and that's going to multiply to 4, and I'm going to add those together. 72 plus 4 is 76. So that's 76 that right? Hold on. We gotta pause here for a moment. Alright, we're good. A little early in the morning for Mr. Ausel, so I want to make sure I don't make any mistakes for you guys. But okay, it's okay. Mistakes are part of the process, right? So, let's go ahead now and simplify this. 76 minus 5 gives me a 71. Let's take away 1 from both sides, so that gives me 70 is equal to 20y, I'm sorry. And when I divide by 70 by 20, I get y equals 3.5. Yes, there we go. That looks good. So, I'm going to box my two final answers. X is equal to 9.5, y is equal to 3.5, and we're good to go. Alright? So, go ahead and try example 4 here if you'd like. Again, pause, rewind the video if you need to, but see if you can get through this example on your own, and then check back with me to see how you did. So the first thing I'm going to do is highlight my variables here, right? I got an x here, I got an x here, and then I have a different variable y right here. So before I find my different variable y, I got to find my x first, because I have that variable in common. So what's the angle relationship that these two angles share? Well, they are a linear pair. They're formed by one pair of opposite rays, and they have a common ray in the middle. So let's go ahead and take 10x plus 3. Let's add to that 16x minus 18. That sum has to be equal to 180 since they're supplementary angles. So we're going to do some adding here. We got 10x and 16x. That adds up to a 26x. Let's take away positive 3 from negative 18. So I end up with a negative 15. We're going to go ahead and add 15 to both sides here. So that's going to give me a 195. And then let's go ahead and divide 195 by 26, and x is equal to 7.5. Now that I've found my x, I'm going to use that and plug that into the relationship that one of the angles share with 12y. So this angle 12y is a vertical angle of this angle right across from it, formed by two pairs of opposite rays. So that means 16 times x, whatever that quantity is, minus 18 has to be equal to 12y. And I know that x is equal to 7.5, so I'm going to plug that in here. And just kind of to combine some steps here as quickly as we can, let's go ahead and multiply 16 times 7.5, which gives me 120. We're going to take away 120 from, we're going to take away 18 from 120, which is going to give me 102. And the last step was we're going to divide 102 by 12, and I get a y value of 8.5. Making sure that I box or circle my final answers. Okay, so we've done a couple examples algebraically. We've also looked at vertical and linear pair relationships. Just to quickly recap here, we do have two other relationships we keep talking about, but it's good that we define them here for us in our notes. So the first thing is that two angles are complementary angles if their measures add to 90 degrees. Add to 90 degrees. And supplementary angles are two angles who measure add to 180 degrees. So we kind of talked about this. There's different ways we can help remember this. I have one p here, that's going to be 90. I have two p's here, so that's going to be 90 plus 90, which adds up to 90 plus 90, which adds up to 180. That's all I was taught. I have some students come in, they say, well, Mr. Ausel, this is like a C, so this C kind of looks like a 9, and this S kind of looks like an 8 if I connect it, kind of. So that helps them remember 180 and 90 in that way. So whatever works for you, just make sure you understand the difference of the two and what they add up to. So if I was asked to find the complement, and we're not talking about complementing your siblings or your mom or your dad here, we're talking about the complement of angles. So if we're trying to find the complement of 27 degrees, that means we're going to look for what what complement plus 27 is going to add to 90. So another way we can quickly do this is go ahead and take away 27 from 90, and that will be what we're looking for. So in this case, when I take away 27 from 90, I end up with an angle measure of 63 degrees. In number 2 here, they're asked to find the supplement of 115. So again, what number plus 115 is going to give me 180, since we're trying to find supplementary angles. So let's reverse that, and let's go ahead and take away 115 from 180 to find our missing angle. So when we do that, we end up with a measure of our supplement being 65 degrees. Okay? And of course, it wouldn't be math class without some algebra. So let's tie in number 3 with a little bit of algebra. They tell me that the following angles, A and B, are complementary. Complementary means when I draw their picture, right, I'm going to have two angles that have to add up to 90 degrees. So let's say I have two angles here that are adjacent, and when I add up angle A and angle B, they have to add up to 90 degrees. 90 degrees. So let's go ahead and take the measure of angle A plus the measure of angle B, and they have to add up to 90 degrees since they're complementary. So let's plug in our expressions for A and B, 5x plus 4 plus 7x minus 10, and let's set that equal to 90 degrees. Again, we're getting pretty good at solving linear equations, but we're going to combine our like terms. 4 and negative 10 is going to give me a negative 6. We're going to add 6 to both sides. And when we divide 96 by 12, we end up with an x value of 8. X equals 8. Now that wasn't what they were completely asking for me in this equation. They were asking also for me to find the measures of the angles A and B. So I'm going to go ahead and go back to my pen here, and I'm going to take my 8 and I'm going to plug it back in to find the measure of angle A. So I'm going to have to do 5 times the quantity of x plus 4. So when I do 5 times 8, I get 40, plus another 4 adds up to 44 degrees. And if I was asked to find the measure of angle B, I would go ahead and plug in 8 into my equation here. Seven times 8 is 56. 56 minus 10 is 46. So my answer here for angle B would be 46 degrees. Now what's one way I can kind of check to make sure I did this right? Well, the nice thing is, what should these two angles, 44 and 46, add up to? They should add up to, when I add them together, they should add up to a 90 degrees. And if they don't, that means I did something wrong. So my final answers are 44 and 46 for this example, example 3. So go ahead and pause your notes here and see if you can try example number 4. It's very similar, but this case we're looking at an example where the angles are supplementary. Supplementary, which means the angles have to add up to 180 degrees. So let's go ahead now and just write out our equation, right? Since they're supplementary, 11x plus 2 plus 8x plus 7 would have to add up to 180. Combining my like terms, 11x and 8x are going to add up to 19x. 7 plus 2 is 9. Take away 9, I get 19x is equal to 171. And dividing by 19 gives me an x of 9. Since x equals 9, they want me to find the angle measures, so I'm going to go ahead and plug that back into my angle measures here. So the measure of angle A is going to be 11 times 9 plus 2, which 99 plus 2 is 101. And the measure of angle B is going to be calculated by taking 8 times 9 plus 7. So 72 plus 7 is going to give me 79 degrees. Also double checking here, 101 and 79 What do those two numbers add up to? 180, so I know I did it right. Alright, last example here for our notes today is looking at an angle pair relationship that form a linear pair. And they give us something a little bit different than what we're used to, so we're going to make sure we go through this slowly here. The measure of one of the angles, so we'll call this angle 1, the measure of angle 1 is 8 times the measure of the other angle, and we'll call the other angle angle 2, right? The other angle we'll call angle 2. So it's 8 times the size of angle 2. So one angle is going to have a relationship to the other, and if it's 8 times as large as the other angle, if the other angle, for example, was like 10 degrees and it was 8 times as large, angle 1 would be 80 degrees, right? If angle 2 was 20 degrees, then the next angle would be 160 degrees, right? Because we're just multiplying by 8 every time, times 8 times 8. So let's say we didn't know what angle 2 was. Let's say angle 2 was x. So what would you do to find angle 1? Well, you'd take 8 times x. Everybody see the relationship we're trying to get to here? So let's say the measure of angle 1 is 8 times x, and let's say that the measure of angle 2 is just x. That fits my relationship, and it also defines each of my angles to each other. So now that I have that relationship and I know that they form a linear pair, that means that we're going to have two angles with one pair of opposite rays, and they share a non-common side, or they share a common side. So what was the relationship that a linear pair had? Well, they had to be supplementary. So let's go ahead and take 8x plus x, and let's add those up to 180. 8x plus x, that adds up to 9x. Let's divide 180 by 9, and what I end up with is 20. 20 degrees. Now all I have to do is make sure I find my angle measures, so I'm going to plug that back into angle 1 and angle 2. The measure of angle 1 was 8 times my x value, 20, and the measure of angle 2 was equal to the x value of 20 degrees. So 8 times 20 is 160 degrees, and the other angle was 20 degrees. There we go. Alright, ladies and gentlemen, we've covered a lot of content here. We've also done a lot of example problems together. So make sure you're going back and reviewing your notes, and then try some practice problems in your homework packet to make sure you understand it. Okay? And we talked about linear pairs, we talked about supplement, complement, and we've also talked about vertical angles. So see if you can apply that now and do some practice on your own. Thanks, and let me know if you have any questions. Have a great day.